Hi guys, and welcome to part 3 of the interactive fog tutorial series. So I've decided to take a slightly different direction with these tutorials. After a little bit of feedback and some thinking, it's definitely going to be a better approach for me to build these things in stages and then come back in retrospect and talk about how I've built them, why I've built them, and we can look at implementing them so that you can also obviously implement the same thing yourself. It just gives me a chance to actually more freely talk about and better explain things as we go through them, because I'm not having to worry about actually building it at the same time and possibly making mistakes, which I then have to go back and fix and explain in further videos, etc., etc. So I think it's going to be a much better format this way. Let me know what you think anyway in the comments, and I'm looking forward to hearing, because I think this is going to be a lot more informative and it should be more concise as well. So we'll jump in and we'll look at what I've actually changed since the last one, and then start to break it down and talk about how and why I've done it that way. Before we do that, however, there is something that I did actually want to start doing with these tutorials as well, which is compiling some of the questions that I've got from people and trying to answer those as well. So far, I mean, I had one question on the last one, which was about this pseudo volume texture here, which I just want to explain quickly before we jump into stuff. And if you guys have any other questions, I'm more than happy to answer them, and I'll do a little Q&A section like this in future videos. I might put this at the end or towards the beginning, I'm not sure yet, but I just wanted to answer this quickly anyway. So the question was about how using a sub-UV texture works for a volume. And basically, as you know, a sub-UV texture is a series of textures in order. So if you thought of these as frames and you went through these in order, this would give you an animation. But in terms of volume textures, think of these as slices in the Z dimension. So instead of an individual frame of animation, this is a sort of frame as we go up through the volume. So this can be thought of in a similar way to how a 3D printer works, or a MRI scanner, for example, where it builds up a volume or a 3D object out of many 2D slices. And that's what this does here. And by converting this to a true volume texture, it means that we don't need to calculate the pseudo volume texture UVs inside the material. We can just pass a UVW in. So creating a true volume texture creates this. And you can see it's split it up into slices here. And if we go into the view mode and trace into volume, zoom in, and we'll disable the alpha channel, then you can see this gives us an actual volume just built up of many slices, which you can sort of see here, like these slight slicing artifacts. So that's what one of those is, and that's how it works. I had a question on that last time, and I just wanted to answer that quickly, so I hope that was helpful. Anyway, we'll get into the actual video now. So where we left off last time, we had the ability to define a base shape from a box, a sphere, a texture 2D, and a volume texture, and that hasn't changed. That's still the same. However, the parameters here you'll see are slightly different. Whereas before we had a box size and a sphere size parameter, we now have a volume size and an edge falloff. And the edge falloff parameter obviously affects the falloff of any shapes that we select. And the volume size now drives the size of all of our shapes. So before, the texture 2D and the volume texture size were relative to the particle size, whereas now they are defined by this volume size parameter instead. So you can see if I select volume texture here, that it's been squashed and it's scaled correctly to this box. And you can see that we also have this box that lets us know the bounds of the volume, so we'll add that as well afterwards. In terms of the height fall off, I've also added that as a component now as well. So you can see if I change this back to box and just put the edge fall off back to 0 for a second. So currently it's set to none, but if I set this to actor position, for example, we have a height fall off of 100. This is just falling off 100 from our actor position. So if we move this, it's sort of fixed to our actor. We also have the ability to do it from distance fields. So you can see that this now is taking in the landscape's distance field as well. So it's relative to our landscape. And we can also use the height capture. And this will look the same as distance field here. And that's because we're using a scene capture to capture the scene's height. But this is good because it means that we can exclude certain actors. So for example, here in this room you can see the sphere is writing into the mask, and so is the landscape, but these three little boxes here aren't. So if I selected this one, and if I go into the height actors here, add, and just pick this box, then we can see that we get some odd looking fog on top of this box. Obviously it's not an ideal use case there, but it shows exactly what we're trying to achieve. So that's what's changed in terms of where we last left off. So now we'll go into and we'll look at the base shape stuff first, just see how I've tweaked and changed that slightly, look how I've set it up, we'll go through how you can set it up and why I've done things the way I've done them, and then we'll go and we'll look at the height capture and everything like that, and we'll set all of that up as well. So then at the end of this tutorial, you should have what I have here, and then doing it this way means that I can get these parts out a lot quicker, so I can do the all the noise and the nice self-shadowing and everything. I'll get that done and have a tutorial out on that very, very soon as well. So we'll get into the base shape stuff first. So we'll take a look at what's changed in the blueprint and in Niagara first, because you'll notice as well when I select this that our particle now also resizes to cover the max size of our volume at all times. So this is also something that we're going to drive with this volume size parameter. So if you open up your fog volume blueprint, in the base shape category before, you'll have the box size and the sphere size. Just rename these to volume size and edge fall off. And in the construction script, this is different, but don't worry about this for now. This is to do with the height capture, so you can ignore the render target stuff. But you want to add a box collision component. So if you go to here and type in box collision, then add one of those. I've already done that here. For now, I'm calling this debug box because this is what we're using to visualize the bounds. But we will actually later on use this as an overlap trigger so that we can capture our interaction, because we don't want to do that every frame, so we're going to be triggering this. But for now, it's for debugging purposes. So you can call it debug box or you can call it whatever you want. I'll just change the line thickness to 1 just so you can see it a little bit better. You can change the color too if you want to. And I've just disabled collision completely for now because, as I said, we'll worry about actually enabling that later on. So once you've added that, it should just be floating there in your viewport, and you just want to set the box extent. So this will always be aligned obviously to the center of our volume, but we want the extent to cover the same as our volume size. So you just need to take your volume size and divide it by 2, and that will be your box extents, because the extent is the extent from the center to the edge. So it will be the total size divided by 2. And that will give you the debug box that you can see here. So that's the only thing that's changed with that respect. And then with Niagara, we're now also using this volume size parameter to drive the particle size. So I've just wrapped these into functions. They were all just out in the graph before, but all you need to do is just drag over them, right click, collapse to function. It just makes things a lot neater. So we've only added one parameter in the Niagara system, and that is volume size max. So in your particle system, under user exposed, just add a new float variable called volume size max, and then in your initialized particle, just put that in your uniform sprite size here. We want the sprite size to be uniform still, and we just scale it so that it always covers our volume. And so then in our blueprint, we just set that to the max size of our volume in any axis multiplied by 2. So that will always cover the volume there. So that will give you a particle that resizes dynamically to cover as little or as big an area as it needs to, and the volume size with the bounding box. So the rest of it happens inside the material. So we'll worry about changing the material variable names in here afterwards. We'll set up the material first and then come in and just make a couple of changes in there. So in terms of the material, things, if we scroll out, will look a little different, but this is all the height fall off over here. So ignore all of this for now. We'll look at that in the next little part. In terms of this, we haven't changed much, but we're now using this volume size parameter, and our box size no longer uses that custom node, and I'll talk about that in a second. So as I said, this really hasn't changed much, but we're just getting the distance from the center of our particle. We're just adding half the volume size so that we get a sort of 0 to, if our volume size is 100, it's a 0 to 100 across the corners, and then we divide that by the size of itself, so it's 0 to 1, which gives us a 0 to 1 UVW, which we can use to read our volume texture. And then the 2D texture is basically the same. However, we just use the RG channels to map the texture downward, and then we use the blue channel here of the UVW. We invert it so that it goes from 1 at the bottom of the box to 0 at the top, and then we can raise that to the power of edge fall off, and we just multiply our texture result by that, and then that goes into our G again as it did before. In terms of the box, this may look complicated, but it's really not. Again, we're just getting the distance here from our particle center, taking this as an absolute value, and then we're just splitting this into the components. And this is similar to what we did in the custom function, but we're now just dividing this by half the volume size so that we get that fall off from 0 at the center, 1 at the edge again, saturating it so it doesn't go above 1, so that when we invert it and we get that 1 to 0 from center to edge, we're not ending up with any negative values at any point. And then we just multiply all of these together and raise that to the power of edge fall off to give us a fall off. There is a better way you could do this. You could do this per axis and you could define it in world units, but for now, we're not going to worry about that. That's something that we could add at some other point. And then I'll talk about this guy here in a second. And in terms of the sphere, we are doing basically what we did before, but instead of using the sphere size, we're taking the minimum of the volume size, which means that if we have a non-uniform volume, then the sphere will always be resized so that it fits within the smallest size or the smallest bounds of that volume. And then again, we just take that to a power of edge fall off to give it some softness. And the shape type parameter, we have that set up from earlier. After we've chosen, we then just multiply this by the sealed result of this box. So what does that do? That just means that whereas before we have a value between 1 and 0 inside the box and then 0 outside, we'll just take this so that any values between 0 and 1 are now 1, and any values that are 0 remain 0. So that means that this basically gives us what our custom function had before. We have a value of 1 inside of our box and a value of 0 outside. So we can use this as a mask to multiply against all of these, which means that the shapes will never extend outside of the volume, which can happen because our particle is bigger than our volume, so that it covers it. So you can that avoids any sort of stretching artifact or anything like that. So hopefully you can get a good view of that. I'll just scroll down a little bit here so that you can pause it if you need to copy any of this. But it's not too complicated and it's not too different to what we had before. This is the only thing that's really changed sort of massively. And as I said, we can ignore this for now. So that will just plug straight into your global extinction, and then that should be everything you need in the material there. We just need to make sure that we go back into our blueprint and change the names of any of these that we've changed in here, which is just 2. So again, this is wrapped in a function, but these were our base shape variables. So you just need to make sure that your volume size is now called volume size in here too, because we renamed it in the material. And the same for the edge fall off. This was your sphere size parameter before, but it's now called edge fall off. So that's sort of exactly how that was set up. It just gives us a much neater way of actually controlling the shapes, and as I said, sort of non-uniformly scaling them and giving us much better control than we had before. So hopefully that all makes sense. There's nothing too complex in there, I don't think. So we'll go and we'll have a look at the height fall off stuff now, which is slightly more complicated, but again, it's pretty simple. So I'll do my best to explain that as well as I can there. For the height capture, we'll take a look at the simplest two first, which is the actor position and the distance field. So we'll look at the material first, and then we'll expose those parameters to the blueprint, and then we'll have a look at the height capture one and how that's set up. So ignore this stuff just for now. We'll come back and look at it in a minute. But in terms of the actor fall off and the distance field fall off, these are very simple, especially the distance fields. It's the same sort of thing as we were doing before. You're just calculating a distance, and then you're dividing that by the amount of fall off that you want, or the distance over which you want it to fall off. Sorry. So in terms of the actor fall off, we're literally just taking the difference between our actor position and our absolute world position in the Z direction. We're just subtracting half the volume size so that this is from the bottom of our volume, not from the center. And that gives us that distance. We then divide it, saturate it, and invert it. And that gives us the height fall off there. So we just use the global height fall off parameter to control that. So you can go ahead and add that, plug this in. Yeah, for now, you can ignore this if you want. If you just want to test this, just plug this straight into a multiply and multiply your shape by this before your extinction or after. It doesn't matter with multiplication. It's always the same. And if you open your instance and drag around that global height fall off parameter, then you should see a change. But in terms of distance fields, this is super simple because we already have the distance. That's what this node does for us. So we just divide that by height fall off, Again, saturate it and invert it. And here we're just doing the same thing that we did for this here. We're appending all of this into a vector 4 so that we can just choose the channel based on a channel selection, so that allows us to change it in the blueprint. So just add a channel mask parameter as you did last time, plug in the RGBA off here, and we'll set that up in the blueprint afterwards. This time I've just called it height method, but you can call it whatever you like. And then in the A channel we just have a value of 1, so that's when we select no height fall off, then we just get no height fall off. We just get our standard volume as we had it before. So in terms of those, it's very simple. That's pretty much all there is to it. So inside your blueprint in the construction script, we just have to set those material variables. So inside here, we now have these new variables, which is just our global height fall off. Ignore this one, as I said, just for now, and our height method. And we just do the same here. So what we did last time, we created an enumerator, which was for our fog shape type. So I've just created another one here, which is called fog height method. And that just has those 4 in there: active position, distance field, height capture, and none. And then make sure that you add this. I've created another category here for the height fall off. Add a variable of type fog height method, or whatever you've named it. And then we can use that as a select node. So we drag off and select, and use this one, not this one, and plug that in, and that will then expose those parameters. And we set those to whatever you plug them into, but for us it was in order, so it's R, G, B, and A. So if we look at this, it's R, 1, 0, 0, 0, same for G, same for B, and then 0, 0, 0, 1 for this. So that's the same setup as we had before. And now you should have the distance field in the active position and the none in there, and that will give you the height fall off from those 3, controllable by your global height fall off parameter. We will also raise this to a power by next time, but that's something that will come in the next part, so I'll cover that then. But in terms of our height capture, that's where things get slightly more complicated, but again, it's not too bad. So we'll take a look at the material first, and this is doing exactly the same thing as the other fall-offs, but instead of where here we're feeding in our active position, for example, to get the distance from the base of our active position, we're now getting the distance from what's stored in a texture, So we're capturing the world height into a texture, and then we're using that as our floor distance, and we're falling off from there. So we'll look at the UV in a minute, but for now this is what's important. So we're capturing to a render target, we're feeding this render target in here, and we're using that as our floor height. So how do we do this? In our blueprint, we'll go in the viewport for now, add a scene capture component 2D, and you can call this height capture, and make sure that your projection type is set to orthographic, so we don't want any perspective or anything in this. Leave the ortho width alone for now, because we'll be setting this in the construction script. And then there's a few things in here we want to change too. So in terms of rendering features, we have post-process materials available, and we're actually going to be using one of these to capture our world height. So just add an array element. So if I remove this for now, add, and then go to asset reference, and then we can choose our post-process material, which we haven't created yet. So we'll have a look at creating that now, and we'll drop that in here. And that's super, super simple. All it is a material with its domain set to post-process. And then we just get the absolute world position, the blue channel, and we just append this into the red channel of our emissive color. And that's all we need to do for this. It's very simple. We'll look at setting up the render target in a minute. We can get rid of this guy for now. And make sure that you then select that in here. So our scene capture is now actually using a post-process material. And if we go down to our actual scene capture options, this is where we set this up. So for our primitive render mode, remember that we want a list of primitives that we want to be able to capture into the height. We don't want to capture everything all the time. So select use show only list from this, and we'll set that list in the construction script soon. And then set your capture source to final color HDR. Now this is the final color with post-process applied. So if you went for scene color HDR, that's your scene without post-process. Final color has the post-process, which we need because we're using that material to render the value that we want. Uncheck capture every frame because we don't want to do this, and uncheck capture on movement, and make sure that you have checked always persist rendering state because we need this for the post-process. If we don't enable this, then temporal anti-aliasing and things like that causes some weird artifacts. And in terms of these show flags, we want to hide everything that we don't care about because we want this to be as cheap as possible. In case we do have to capture this more than sort of once, or we want to do this fairly regularly, this needs to be cheap. So the only things we really care about is capturing geometry in here. So this is the list of everything that I have as set up. So BSP, I mean, a lot of the time you won't be using this anyway in the final game, so that's not too important, but I've left it in. Of course, landscapes, skeletal meshes, static meshes, and translucent meshes as well, and instant static meshes in here. We don't care about foliage and grass or any lighting, anything like that. So all of that can be turned off, and lighting in here can be turned off as well. Post-processing needs to be left on because we're using that post-process material. So that's everything that you need to do to set up your height capture. Don't worry about its rotation or its position because that is set in the construction script, which we'll take a look at now. So I've created another function here called height capture setup, and in the construction script as well, we now create a render target 2D, which is what I told you to ignore earlier, but this is important now. So make sure you add this, and the width and height, we could set this if we want, but 256 for now is all that we need. And we only care about one channel of data, so we can set this to be a red channel only. And dependent on the project, you could also get away with this being an R16. I've set it as 32 here because this will cover all use cases. If you put this volume sort of higher or lower in the world than 65,500, then you will run into precision issues with R16. So that's why I've set it to HDR or R32F for now. So you just need to make sure that you drag off, promote that to a variable so that we have this stored, and that is your render target created. We do it in the construction script and not on disk because we want multiple instances of this blueprint in our world, and they all need their own render target, so they can't all be trying to write to the same one stored on disk all the time. So once you've got that done, in the height capture setup function, this is where we set the position and rotation of our height capture. So the position, we want to just position it at the center of our volume in the XY, and then the Z is just going to be at the top of the volume because we always want to capture from the top down. So we just take the actual position and then we just add half the volume size in the Z direction, and that will give us the center top of our volume. And in terms of the rotation, you just want to set this to -90, -90. This means that when we read our texture or map it inside a material, it's the correct rotation to begin with, so we don't need to worry about rotating it inside the material editor or anything like that. So that should give you the correct position and rotation for actually capturing. And then we want to set the orthographic width as well to the max size of our volume, so that the largest extent of our volume is always covered by the texture, and the texture will always be square, otherwise we start to sort of run into weird issues, which we won't get into here. So we just need to make sure that that's always mapped to that size, and then we need to make sure that our capture is also capturing to that render target that we created. So you just need to make sure that you set your texture target to the render target, and then our show only actors, we set this array, which is just an array of the actors that the scene capture can see, and you just drag off here, promote this to a variable, and again I put this in the height falloff category, and that just allows us to create that array of actors that we want this to be able to capture. Now I've also captured the height inside the construction script. This just means when you move the volume around it will always capture, but this is a separate function because I've made it callable in editor so that you can capture whenever you want as well, just clicking the button. But this is all this does is just capture scene. It's just wrapped in another function so that we can use it. So in here you can see you can capture height like that if you want to. So in terms of the setup for that, that's pretty much everything. So once we've got our render target captured, then we need to feed this into the material as well. So as I said before, you have this height RT, as I've called it here. This can be a texture sampler parameter or a texture object parameter, it doesn't really matter. And call it obviously whatever you want, but then just make sure that in here you expose a new texture parameter value, and you call it whatever you've called it in your material, and you plug your render target into there. So now that we're always reading from that render target inside of our material. So we're now capturing the height feeding it to a render target, feeding that render target into the material to calculate our fall off from that position. And the final part of that is just calculating the UV to read that from. So again, this is pretty simple. We just take the distance from our current position to our active position in the XY. We add half the max volume size. So that means, because our texture is not perfectly fitted all the time, it's square. So we need to make sure that we just take the max of that and we add that to it. We then divide that again by the max and saturate it. And that will give us the UV that we need to read our volume will now read our texture in the correct position. And you can see that all that works because when we set this to height capture here, it's capturing there. And as I demonstrated before in here, these can capture different meshes as you remove these. So that cube, for example, if I just get rid of that, it's gone. And doing this, when I've got the capture set up in the construction script, as I said before, so by capturing it in here, just means that when we actually change any of these values, it will recapture. If we didn't do that, then when we change something in here, we'd have to click capture height. So that's the only reason it's in there. But that should be everything that you need then to set up what I have here. So we have the base shapes that we can now define. We can define our height fall off, and we can define our height fall off from either distance fields or our active position, none, height capture, various different methods. So in the next part, we'll actually add all the noise, the self-shadowing, and the really interesting material sort of features. We'll look at the flow as well and how we can calculate that using distance fields. And then the final part will be the actual interaction itself, which is going to be possibly the most complicated part. But again, I'll do my best to try and talk you all the way through it. So I hope this was helpful. I hope it was better in this format than it normally is. Please let me know, and I will see you in the next part.